I am Santosh Narayan from Persistent Systems, and I will be your trainer for this session on web services. In this session, I will give you an overview of the two widely popular mechanisms of implementing web services, that is REST and SOAP. This session is part of online trainings organized as part of the Smart India Hackathon 2017. Welcome to this session on web services. At the end of this session, you will be able to understand what is a web service. As mentioned earlier, there are two mechanisms of implementing web services. One of them is known as REST and the other one is known as SOAP. We will begin with looking at what REST web services are all about, and then we will cover SOAP a little later. Web services can be implemented on any language or platform of your choice. Java is the programming language which we will be using for implementing our web services, both in REST as well as SOAP. At this point, you should have a decent understanding of writing web applications on the Java platform and also a fair bit of understanding of the HTTP protocol. So let us ask ourselves a very basic question. What is a web service? If you look closely at the term web service, web refers to what is known as the World Wide Web. And when you talk about a service, you are referring to what are commonly known as business services. Collectively, the term web service basically means a way to expose the business services of your applications over what is commonly known as the World Wide Web by using its most frequently used protocols. There are certain examples of web services out there on the web. One of the most common examples of web services is AccuWeather. If I go to Google and if I try to search for AccuWeather's REST API, the Google results brings up the very first link, which leads me to a page which gives me the description of AccuWeather's REST API. AccuWeather, as most of you might be aware, provides weather-related services. If you look at your smartphone, there might be an app on your smartphone which could perhaps tell you the current temperature of your city. The question that you need to ask yourself is, where is this weather data perhaps coming from? This weather data is coming from a portal on the World Wide Web. One of the portals from where this data could come from is AccuWeather.com. This basically means that the weather related services that are provided by this portal are being used, or you can say consumed, by the Android application on your smartphone. Similarly, another very common example of web services is Twitter. Twitter, as some of you might be aware, has its own web service API, which is based on REST. If you again go to Google and try to search for Twitter's REST API, it brings up a very first result which leads you to a page which gives you the documentation or description, you can say, of Twitter's REST APIs. If I were a web developer, for example, writing my own web application, what I can basically do is I can write code in my web application which can invoke these services provided by Twitter. What kind of business services does Twitter provide? Twitter, as all of you know, provides social networking services. So I could write an application which perhaps consumes the tweets or retrieves the tweets that are being made on Twitter's servers. This is another very common example of web services. So to summarize, a web service is a mechanism to integrate many different kinds of software systems. These software systems need not necessarily be implemented on the same platform or on the same language. There is a possibility that the web service API that you have designed or you have created might have been implemented on Java. But the clients or the applications which consume these services or use these services might be implemented on some other platform. So what you are effectively doing is by implementing web services, you are allowing many different applications written using many different technologies interact with each other by exchanging data between themselves. And how is all this being done? All this is being done by using the World Wide Web and by using its most common communication protocol, that is the HTTP protocol. There are two very popular ways of implementing web services. They are REST and SOAP. REST stands for Representational State Transfer, whereas SOAP stands for Simple Object Access Protocol. REST is an architectural style. Now, a lot of you might already be aware of the currently prevalent architectural styles which are used for designing your applications. For example, some architectural styles that you might be aware of are the client-server architecture, or at the application level, the MVC architecture. Like any architectural style, REST has many different components. Every component in an architectural style has a key role to play, and that applies to REST as well. We will discuss the various components of the REST architecture in a short while. But before you do that, you need to answer a question, and that is, why do you need a web service? These are some of the reasons why you would perhaps need web services. They allow you to expose or aggregate existing functionality or business services of your application. These business services could be then shared by many different applications or could be used by many different applications. They allow applications running or implemented on different platforms to interoperate with each other by exchanging data between themselves, and they make use of the currently available protocols to do this. Let us talk about REST web services. The two most important components of the REST architecture are resources and resource identifiers. Let me talk about resources first. When you look at the term resources, you have to think about it from the World Wide Web's perspective. Some common examples of resources on the World Wide Web could be, let's say, for example, a HTML page, an image, and so on. If you were to access a HTML page, you need to know the URL of that page. For example, this could be the URL of some HTML page. Similarly, If you need to access an image, you need to know the URL of that image. If the HTML page is the resource, the URL that is used for accessing that page is known as the resource identifier. If an image is considered to be a resource, the URL that is used for accessing that image is considered to be the resource identifier. The REST architecture says that if you were to deliver business services by using REST, then what you ought to do is you have to design a set of resources which could be used for exposing the business services of your application. How would you access these resources? You would access these resources by using their URLs. What would happen when you access these resources? When you access these resources in turn would access some business services of your application. These business services could be, let's say, for example, weather related services like the ones that AccuWeather provides, or social networking services similar to the ones that Twitter or Facebook provides. The second key element of the REST architecture is the representation. Since the whole idea behind implementing web services is to allow applications to exchange or interoperate between themselves by exchanging data between themselves, the question that needs to be asked is, what kind of data or in what format can this data be exchanged between these applications? The data that can be exchanged between these applications is known as the representation of your resource. This representation could be in two very popular formats. One of them is XML and the second one is JSON. So let's say, for example, if I were to access a particular business service on the Twitter API by using a resource that is available in the Twitter's API, I would access that resource by using its URL. I would send a request using the HTTP protocol to access that URL. What would be the outcome of that request? The outcome of that request would be a response which would perhaps contain the details of the tweet that I intended to access. These details could be in two of these formats, either XML or JSON. Another key element in the REST architecture is a connector. A connector is the protocol under which communications are done using the REST architecture. This protocol is the World Wide Web's most commonly used protocol, that is the HTTP protocol. A component is an element in the REST architecture which drives the interaction between a client and the server on which your web services are running. A client could be something as simple as a web browser, or something a little more complex. Let's say, for example, a console application written in C++. The server is the one where the resources are hosted. When these resources are accessed, these resources produce a result, and that result is the response. So now the question is, how do you implement REST web services in Java? Java has two APIs for implementing web services. One of them is known as JAX-RS and the other one is known as JAX-WS. JAX-RS stands for Java API for XML RESTful web services, whereas JAX-WS stands for Java API for XML web services. JAX-RS is the API that is used for implementing web services using REST, and JAX-WS is the API that is used for implementing web services using SOAP. There are certain implementations of both of these APIs that are available. The implementation that we are going to use of the JAX-RS API is Jersey. A few other implementations are, for example, REST-Easy, Apache Wink, and others. You can download the latest version of the Jersey APIs from jersey.java.net. There are two versions of the JAX-RS API that are right now being used. One of them is JAX-RS 1.0, or you can say 1.x, and the other one is JAX-RS 2.x. The version of the API that we are going to cover is going to be 2.x. The version of Jersey that we will be using will be 2.x. So now the question is, if you were to implement REST-based web services in Java, then what is it that you have to do? The first thing that you have to do is create a dynamic web project in your Eclipse IDE. I'm going to call this application Tienda. We will be taking a case study based approach to implementing REST web services in Java. Let me show you the case study first. So here it is. This is the case study that we will be implementing in our application. We will be writing a RESTful API using this case study. So tienda.com is an online fashion portal, and they have these list of products and a few users who are registered on the portal. Every user has placed some orders. The orders information has been given here, and every user also has a wish list. Our objective from this case study is to design a RESTful API which can do all of the operations that are listed over here. So to begin with, we have created a dynamic web application in our Eclipse workspace. The first thing that I will do in this application is create a series of packages. Let's start with creating a very basic Java Bean class. The first class that we will create will be user. User will have properties like user ID, username, and email. I'll write setters and getters for each one of these properties, and also write two constructors for initializing these properties. The second class that we will create will be order. So order status is going to be an enum. I'll create an enum in the util package. The two possible values will be active and cancelled. And product will be another Java Bean class. Product will have attributes like I'll write setters and getters for product. And I'll also write a parameterized constructor and a without parameter constructor. In the order class as well, we will generate the required methods. The last bean class that we need to create will be wishlist. So that does it with all the Java Bean classes that we will need. So what we will need to do first is we will have to prepare the boilerplate code which can be used for implementing our REST web services. And the first step to implementing that code would be to create these required Java Bean classes. The next thing that we will do is, in the service package, we will create a class. Let's call it t&service. This class will have a series of methods wherein every method represents a certain kind of business service. Out of all the methods that might be there in the t&service class, we may decide to expose some of these methods to a client by designing a bunch of resources in REST using the JAX-RS API. So let us first get down to implementing the business services. Before you implement the business services, if you look at the case study that we just saw, you will see that there is a lot of data that has been given in that case study. Data related to a product, data related to the registered users on the portal, the data related to the different orders that a user has placed, and the wish list of a user. Now, though it is very much possible for us to use a database to store all this data and fetch all that data from a database, what we will do instead is we will hardcode all that data into certain in-memory data structures. So what we now have is a class called data store. If you look at the class, you will see that we have declared a lot of data structures over here. Every data structure is being used to store the data that was given in the Word document that we saw earlier. So the first list over here stores the details of all the users. The second list over here stores the details of all the products. The third list over here stores the details of all the orders made by the users. And the last and the final list over here stores all the wish lists of all the users. We have written a static block in this class wherein we have hard-coded all the data that was given in that Word document. Apart from this, what we have also done in the data store class is we have written a series of methods like getUser, for example, which takes the username as argument, and returns a user object by looking up for that user in the list of user objects that we had declared earlier. If the user is not found, this method throws a user not found exception. User not found exception is a custom exception class that we have created. This is one of the many exception classes that we have created in this application. For example, apart from user not found exception, we also have order not found exception, product not found exception, and wishlist not found exception. All these exception classes have a superclass, and the superclass for all these exception classes is T and exception, which inherits from exception. There is one additional class that we have created, a Java Bean class that we have created to store the exception message. The name of that class is exception message. This class has one string property which stores the exception message. We have written setters and getters for this property, and we have also generated some constructors in this class. So now let us get down to writing the business service method. The first business service method that I will write over here is a method which retrieves the details of a user. The method will have one parameter, that will be the user name, and it will invoke a particular method in the data store class to fetch the details of a user. Since the data store method throws an exception, we will add a throws clause to this method. At this point, we do not intend to write a try catch block inside this method to handle this exception. This is our first business service method, which, given the user name, returns the details of that user in a user object. Another business service method that we will write will return the details of a product. This method will throw an exception as well. That is the second business service method that we have written, which uses the product code to fetch the details of a product. The third method that we will write will fetch the details of an order. The third business service method returns the details of an order for a particular user. Get wishlist for user. This method will return the details of a wishlist given the username. The last method that we will write will attempt to return all the orders that belong to a particular user. That completes all the business services that we intend to implement at this point. Of course, we could have implemented more business services as well. For example, we could have implemented a business service method that could be used to create a new user. We could have implemented a business service method to create a new order. We could also have implemented a business service method to remove a user's wish list, and so on. Right now, these are the business service methods that we have implemented. If there is a need, we will implement the other methods a little later. Now, as we have been discussing since the very beginning, the whole idea behind REST is to allow clients access to these business services that we have written. The REST architecture says that to be able to do this, you have to design a set of resources which can be used for accessing these business services. So that brings us to the next most important question, and that is, how do you design these business services using the JAX-RS API? JAX-RS, as we discussed a little while back, is the API that is used for implementing RESTful web services on the Java platform. The implementation of the JAX-RS API that we intend to use is Jersey. Before we get down to implementing or creating resources using Jersey, we need to include the Jersey libraries into this project. If you have already downloaded the Jersey APIs from Jersey's website, that is jersey.java.net, then these are the jar files that you should be having with you at this point. What I am going to do is to add these jars to my project. I'll take a copy of these jars and add them to the lib folder in my dynamic web project. The lib folder is found inside the web.inf folder. So you just have to take a copy of all those jar files and you have to keep them inside the lib folder of your project, of your Eclipse project. So once you are done with that, we are all set and good to go to implement our first resource. To create a resource using the Jersey APIs, the only thing that you have to do is create a class in Java. Let's call this class user resource. This class need not implement any special kind of interfaces, or it need not inherit from any kind of special classes. To designate this class as a resource class, this class has to be annotated with an annotation which is known as path. The path annotation comes from the JAX-RS APIs. When you designate this class with the path annotation, you can give the URI path that can be used for sending a request from the client side for accessing this resource class. If you remember what we discussed a little while back, the two important components of the REST architecture were resource and resource identifiers. So if the class is the resource, then this is the resource identifier. The URL path that has been mentioned in the path annotation is the resource identifier which can be used for accessing this resource class. Now, since this class is like any other standard Java class, this class can have methods. Let's say, for example, I can write a method in this class which can be used to fetch the details of a user. If this is your resource class, then this is your resource method. You can apply the path annotation on top of the method as well. Right now, we need not do that. We will do that a little later. The question that you need to ask yourself at this point is, what is this resource method expected to do? If you look at the name of the method will attempt to fetch the details of a user given the username. We already have written a method in the T&R service class which contains a business service method to fetch the details of a user. We can invoke that method from here. The business service method might possibly throw an exception. Right now, we do not intend to write any try-catch block in this method to handle that exception. So I'll simply add the throws clause to this method. So this is your resource method. When a client sends a request by using the HTTP protocol, the client will use the URL to access this resource method. Before you allow a client to access this resource method, there are certain decisions that need to be taken. One of the decisions that needs to be taken is which HTTP method should be used for accessing this resource method. If you remember, HTTP has a lot of different methods. For example, get, post, put, delete, options, trace, and so on. Now, out of these many methods, these are just some of the methods that have been listed over here. Out of these many methods that are there in the HTTP protocol, which are the methods that are most relevant for implementing REST web services? The methods that are most relevant for implementing REST web services are post, get, put, and delete. And the reason why these methods are the ones that are most relevant is because each one of these methods can be mapped to a particular operation in CRUD. Post can be mapped to a create, get can be mapped to a read, or you can say retrieve, put can be mapped to an update, and delete can be mapped to a delete. So each of the 4 operations in CRUD, create, retrieve, update, and delete, can be mapped to a particular HTTP method. Considering this, if you look at the resource method that we have just written, fetch user details, this method, since it intends to fetch the details of a user, or you can say read the details of a user, or retrieve the details of the user, the method that it should be mapped to should be a HTTP get. That basically means that this resource method should be accessible with a HTTP get request. So when a client sends a request, the client should use a HTTP get request for accessing this resource method. How can you designate this method to be accessible with a HTTP get? This can be done by annotating this method with an annotation which comes from the JAX-RS APIs, and the name of that annotation is get. The other key component of the REST architecture that we discussed a little while back, if you remember, is a representation. There are 2 popular representations which are commonly used with REST web services. They are JSON and XML. A representation basically tells you the format in which data would be exchanged between a client and a RESTful web service. In this case, this particular method, fetch user details, returns a user object. User, as you know, is a Java object. When you return the details of a user to a client, these details will have to be transformed into either XML or JSON, and a HTTP response will have to be sent back to the client which contains the user details. How can you do that? You can do that by applying another annotation on top of this method, which is known as produces. The produces annotation has a value attribute which takes a string array as argument. This string array could be all the possible MIME types. The term that we are using over here is MIME. All the possible MIME types, or you can also say media types, into which you intend to convert a user object into. Right now, I can say that I intend to convert the user object into JSON. So the MIME type for JSON is application/JSON. Now there is actually a better way of writing MIME types. Instead of writing hard-coded strings like this, what you can basically do is you can use predefined constants in a class known as media type. The media type class comes from the JAX-RS APIs, and this class has a lot of public static final constants, public static final variables, wherein each one of these variables represents a particular MIME type. For example, this particular variable over here, application_JSON, represents the MIME type application/JSON. That's it. This is what you have to do to implement a resource in the JAX-RS API. Now if you look at the resource method that you have written, you will see that the resource method has one parameter, which is the username. This basically means that when the client uses a URL for accessing this resource method, the client is expected to pass the username in that HTTP request. Now the question is, what mechanisms are available to pass the username, particularly in a HTTP GET request? There are two mechanisms available for passing the username in a HTTP GET request. One of them is by using what is known as a query string or a query parameter. A query string or a query parameter is something like this. This is the name of the parameter, and this is the value of the parameter. A query parameter appears always at the end of the URL, and it is separated from the URL by using a question mark. If there are multiple query parameters, they are separated by an ampersand. This is one of the mechanisms that is available to pass the username in a HTTP GET request. If the username is passed as a query parameter, we need to extract the value of the username and store it into this string variable. You can do that by annotating this method parameter with an annotation that comes from the JAX-RS API. The name of that annotation is query param. You have to specify the name of the query parameter. For example, in this case, the name of the query parameter will be uname. That completes our resource method. The next step for us is to deploy these resources on a server and access them by using a client. To deploy them on a server, the Jersey APIs provide you many different deployment options. One of the ways to deploy these resources on the server would be by creating a class which inherits from a class called application. In the util package, I'm going to create a class. Let's call this class application. This class will inherit from a class which comes from the Jaxaris APIs. The name of that class is application. After inheriting from this class, we will override a method in this class called getClasses. If you look carefully at the signature of the method, you will see that it returns a set of class objects. Inside this method, I'll create a set and I'll add the class object of the resource class that we have created. The idea behind creating the application class is to tell your Jersey runtime all the resource classes that you have created. This is one of the deployment options, one of the many deployment options that are available in the Jersey API. The application class needs to be annotated with an annotation which is known as application path. You can optionally specify an application path over here. We will look at the implications of specifying a path over here a little later. Right now, I'm going to give the path as /, which means I'm going to bind the path to the application's root path, or what is also known as the context path of the application. So now we are good to go and deploy this application and the resources on a server of our choice. Since this is a dynamic web project, this project can be deployed on a Java EE server. The server on which we are going to deploy this application is going to be Tomcat. I'll right click on the project, go to Run As, and click on the Run on Server option. Now, since we have not added the server while creating the project, we will have to add the server here on which we intend to deploy this project on. We intend to deploy this project on the Tomcat 7 server. You have to choose the Tomcat installation directory over here. We will deploy this project on the Tomcat 7.0.30 server. Now, once you have deployed the project, you will see that Eclipse attempts to open the root path of the application in its own inbuilt browser. For a REST web service, a browser may not necessarily be the right kind of tool for testing your web services. The reason being, a browser can only send a limited type of HTTP requests. A browser is primarily designed to send either a HTTP GET or a HTTP POST request. But with a RESTful API, there are other kinds of HTTP methods which might have been implemented. Instead of using a browser, there are certain plugins which can be used for testing your REST web services. For example, on the Chrome browser, there are two popular plugins available. One of them is the Advanced REST Client, and the other one is Postman. You can use any one of these plugins to test your REST web services. We will be using Postman to do this. So what you need to do next is, you need to take a copy of this URL, that is your base URL, the base URL of your application. The base URL, as I said, is also known as the context URL. On the context URL, you have to add the path of the resource that you intend to access. If you look at the application that we have written, you will see that we have created one resource class, and that resource class has a URI path of /users, which means if I intend to send a HTTP request for accessing this resource class, I need to add the URI path of this resource class to the base URL. Now, though we could have annotated the resource method as well with the path annotation, right now we have not done that, which basically means that this URL should be more than sufficient for us for sending a request to access this particular resource method. This resource method has one parameter, and that parameter is the username. The client is expected to specify a query parameter at the end of the URL which contains the username. The name of the query parameter should be uname. The name of the query parameter followed by equal to and the value for the query parameter. Please note that these values can be taken from the data that we have hard-coded in the data store class. Before you send the request, the next thing that you have to decide is which is the HTTP method that should be used for sending this request. The resource method that we have implemented takes a HTTP GET request. So we need to choose a HTTP GET method to send the request. You can choose the method in the Postman plugin from this list over here, and then you can click on the send button. The moment you do that, the Postman plugin sends a request using the HTTP protocol. That request is received by the Jersey runtime. The Jersey runtime in turn analyzes the different aspects of the request. For example, the URL which was used to send that request, the HTTP method which was used to send that request, and any possible headers that might have been set while sending the request. In this case, the two elements of the request that are analyzed are number one, the URL which was used to send the request, and the HTTP method which was used to send this request. After analyzing these many aspects of the request, the Jersey runtime tries to look for a resource class which can be instantiated to further process that request. In our case, the URL had /users, and we have a resource class which has been annotated or mapped to the /users URL. So the Jersey runtime in this case now creates an instance of this resource class. This is like any other ordinary Java class, and it then invokes this particular method, the only method right now that is there in this resource class. What does this method do? This method in turn invokes some code on your business layer, that is the T&A-service class. That T&A-service class has a method getUserDetails which fetches the details of a user given the user name and returns a user object. That user object is returned to this resource method, and the resource method ultimately attempts to return the user object. This user object is returned back to the Jersey runtime which had originally processed the request. At this point, the Jersey runtime decides into what format this user object needs to be converted into. This decision is taken on the basis of what has been written in the producer's annotation on top of the method. The producer's annotation on top of this method here says that we intend to convert this user object into JSON and return it back to the client in a HTTP response. At this point, the Jersey runtime will take the user object and convert it into JSON. To convert it into JSON, it uses an API which is known as Moxie. So Moxie is the API used by Jersey, which is used for converting your domain objects into JSON. Domain object basically means your Java Bean objects. You can also send the username as part of a URL path. Let's say, for example, I can send the username as part of the URL path by appending it to the end of my URL. This is known as a path parameter. To be able to use path parameters in a RESTful API, you need to use an annotation which is known as path param. You also need to annotate your resource method with the path annotation, and you need to specify the name of what is known as a template parameter. The template parameter is enclosed in a pair of curly braces, and it is a placeholder for the actual username in the URL path. The path param annotation should have the name of the template parameter. Let's try to deploy this on the server. And let us test it again with the Postman plugin. In this case, instead of using a query parameter, we will pass the username as a path parameter. The request will be a HTTP GET request as usual. And you again receive a response back from your RESTful API, which gives you the details of a user in JSON. Now we have already seen how we can generate JSON responses, and we also know that Moxie is the API that is being used by Jersey to generate a JSON response. But JSON is not the only format that is used or that can be used with a RESTful API. A lot of RESTful APIs are also designed to produce data in XML. Jersey can also help you generate an XML response. To be able to do this, the first thing that you have to do is you have to annotate your Java Bean classes with an annotation which comes from the JAXB API. JAXB stands for Java API for XML binding. The annotation that you need to use from the JAXB API is XML root element. This annotation should be applied on top of your Java Bean class. This is the only annotation that you need to technically use to be able to convert an object of the user class into XML. The next thing that you have to do is, in the producer's annotation, you need to specify the media type which would be application underscore XML. Application underscore XML represents the MIME type application slash XML. Let's deploy this project again on the server. And let's try to access it with the Postman plugin. But now when you try to access it with the plugin, since the resource method that we have written has been written in a way that it can generate both XML as well as JSON responses, you need to somehow, via your client, tell your server what kind of response do you expect from your RESTful resources. This can be done by using a header in the HTTP protocol, which is known as accept. The value of this header could be the MIME type in which the client intends to receive a response in. For example, in this case, I am specifying the value of the accept header to be application slash XML. This basically means that I intend to receive the response in XML. There it is. If you change the value of the accept header to JSON, for example, you should be able to generate a JSON response from your RESTful web service. That brings us to the end of this overview session on REST web services. If you have any questions, please do post a comment on the comment box. Now we will discuss how you can implement web services using SOAP. At the end of this part of the session, you should be able to understand what SOAP is. I'll give you an overview of what SOAP is. As usual, there are a few prerequisites for learning SOAP effectively. Number one, you should be familiar with the Java programming language on which we are going to implement SOAP based services. And number two, you should have a sufficient amount of knowledge of writing web applications using the Java platform and the XML standard. So what is SOAP? SOAP stands for Simple Object Access Protocol. Now if you look closely at what it stands for, when you are talking about an object, you are talking about an object created using an object-oriented language like Java, for example. At this point you should be asking yourself a question, and that is, what is it that is accessible in an object? It is the methods in an object that are usually accessed. Being a protocol, SOAP has a set of rules like any other protocol. These rules are based on XML. SOAP uses the HTTP protocol as the transport medium, unlike REST, which uses many different aspects of the HTTP protocol, like the headers, the different status codes and other things that are there in the protocol. SOAP simply uses HTTP as a transport medium to transport SOAP messages from the client to the server and receive a response in terms of a SOAP message from the server. This SOAP message is actually an XML document. There is a particular format, or you can say form, of this XML document, and that is the reason why we call it a protocol in the first place. The API that is there in Java for writing SOAP based services is JAX-WS. JAX-WS has a couple of implementations. Some of these implementations are bundled with different application servers. We will be using one of the implementations of the JAX-WS API. The different implementations of the JAX-WS API that are available are, for example, Metro, Apache CXF, and Exist2. The implementation that we are going to use is going to be Metro. Metro is bundled with the Glassfish application server. So when we design our SOAP web services, we are going to deploy them on the Glassfish 4.1 server. As usual, we will take a case study based approach to learning SOAP. So let us take a look at a case study first. This is the case study that we are going to implement. So in an e-commerce system, users can place orders for different products, and products can have coupons which provide discounts to a user on the order value. You are expected to design a SOAP based web service which can perform the operations that are listed over here. The first thing that we would do is we will create a dynamic web project in our Eclipse workspace. Let's call this project Shipcart. We are going to deploy this project on the Glassfish server. So though you can add the server later on after having created the project, we are going to add the server at this point while creating the project. Glassfish 4 is the server of our choice.
As usual, we will get started with creating a few Java Bean classes. The first Java Bean class that we will create is going to be item. Item will have properties like item ID, item code, name, description, and price. I'll write setters and getters and the constructors in this class. Now, since SOAP deals with XML, it should be possible for us to convert objects of your domain classes, that is your Java Bean classes, into XML. As you already know, this can be done by using annotations that are available in the JAXB API. JAXB stands for Java API for XML binding. We had earlier used the same API when we developed RESTful web services, and we are going to use the same API again. To use JAXB, the item class has to be annotated with the annotation XML root element. There are a few more annotations from the JAXB API that you can optionally use. One of the other annotations that we will be using here is the XML attribute. This annotation will make item code as an attribute to the item element in the XML. The next class that we are going to write is going to be order. Order will have attributes like order ID, the order number, the date on which the order was made, and the date by which the order will be delivered. Every order will have a coupon. and a collection of items which are part of the order. Now right now we do not have the coupon class, and that is the next domain class that we intend to generate. So I'll point to the error and I'll say that I want to create a class called coupon. You will create this class in the bean package. And the coupon will have a name and the percentage discount. We will be annotating the coupon class as well with XML root element. Since one of the service methods that we intend to implement is the one where we can retrieve the details, where a client can retrieve the details of a coupon, it should be possible for us to take a coupon object and convert it into XML. And the only way you can do that is by using annotations from the JAXB API. Now, as discussed earlier, technically speaking, XML root element is the only annotation that you need to use from the JAXB API. There are a few more annotations from the JAXB API that can be used optionally if you want. For example, in this case, I do not intend to send the coupon ID in a SOAP response that comes from the server. If I don't want to send the coupon ID in the response, I can mark the getter for coupon ID with an annotation which is known as XML transient. I also want the name and the discount to appear as attributes to the coupon element. To do this, you can annotate these methods with XML attribute. I will also be overriding the equals and the hash code method for the coupon class. Let's go back to the order class. In the order class, the first thing that I will do is generate the required methods. We will annotate the order class with XML root element. In the order as well, when a SOAP response is generated from the web service, I do not intend to send the order ID in the response. So I'll mark the getter for order ID with XML transient. I also want the order number to appear as an attribute to the order element. And I want all the other attributes to appear as child elements to the order element in XML. The item details in XML will be wrapped in a parent element called items. To do this, I am going to use an annotation which is known as XML element ref. XML element wrapper, sorry. And lastly, I will be overriding the hash code and the equals method in the order class. I'll also override the toString method. Now let's go back to the item class. In the item class, I'll mark the item ID as transient. Name as a child element to the item element in your XML. Name as well as description. And price. Lastly, I will override the hash code and the equals method. That does it with all the required Java Bean classes that we needed for the system. The next step for us is to create an interface which contains a series of methods which represent the different business services that we intend to implement as part of this system. To do that, I'll firstly create a package in this project. And in this package, I'll create an interface. Let's call it Shipcart Service. One of the methods that I am going to write in this interface is a method which returns the details of an order. This method will have one parameter, and that will be the order number. Another method that we will write in this interface is a method which returns the details of an item. So what we have now in this interface is 4 different methods which represent the different business services that we intend to expose to a client. Of course, I could have written more methods as well to represent other business services as well. For example, I could have created another method to add a new item. I could have written another method to add a new coupon, and so on. Right now, these are going to be the set of methods for which we are going to write services. In the JAX WS API, an interface which represents your web services should be annotated with an annotation which is known as web service. You can specify a name to the service. Every method that is there in this interface can be further annotated with an annotation which again comes from the JAX WS API. The name of that annotation is web method. The parameters of this method can be annotated with an annotation which is known as web param. Some of these methods return back an object. For example, the first method, getOrderDetails, returns back an order object. You can further annotate how these results will be presented to the client in XML by annotating these methods with an annotation known as webResult. So this should be your first step, creating an interface which has different methods which represent your business services. The next step is going to be creating a class which implements all the methods in this interface. This class should also be annotated with the web service annotation. Here, you must specify the value of an attribute endpoint interface. The value of this attribute should be the package qualified name of the interface that this class implements. Inside the class, it's not necessary to annotate these methods again with the annotations that had been earlier applied on the methods of the interface. So these annotations like web method and web result are optional. You can remove them from the class. Since methods in the interface have already been annotated with these annotations, the only thing that you need to do now in this class is you need to provide a definition for these methods. So you need to write all the business logic code that needs to be written over here to fetch the details of an order, to fetch the details of an item, to fetch the details of a coupon, and to create a new order. As usual, you can either write code over here which perhaps invokes methods on a DAO, for example, a data access object that is, and that data access object might execute queries against your database to fetch data from the database. In this case, we do not intend to use any databases. So what we are going to basically do is we are going to hardcode all the data into certain in-memory data structures, and then we are going to use a DAO to fetch all that data from those in-memory data structures. Before you do that, another annotation that is optional for you over here, which was automatically generated because you implemented the interface, is the web param annotation. Since we have already annotated the parameters in the interface with web param, you need not annotate the method parameters in this class again with the web param annotation. So we'll create a new package in this application. So we have the DAO package in this application, which will have a class which invokes or which contains a lot of hard-coded code. So what we have now is a class shipcart DAO in the DAO package. If you look closely at the class, you will see that we have created some in-memory data structures to store details of an item, order, and coupons. Then we have written a static block which randomly generates some items, orders, and coupons. Apart from this, what this class also has is a series of methods. For example, a method called getOrderByNumber, which takes the order number as an argument and returns an order object. Another method that we have in this class is a method getItemByCode, which takes the item code as an argument and returns an item object. And one last method, two more methods that we have in fact, is a method which returns the details of a coupon by ID and a method which creates a new order. Some of these methods throw an exception. For example, the method getCouponById throws a coupon not found exception. This is a custom exception class that we have created. Similarly, methods like getItemByCode, getOrderByNumber also throw a few exceptions like item not found exception and order not found exception. These are also customized exception classes. These exception classes have been created in the util package, in the in.shipcart.util package. So we have this class coupon not found exception, and then you have the class item not found exception, and lastly we have order not found exception. So the next step now for us is to write some code in the shipcart implementation class which will invoke methods on the DAO that we have just created. Since this method will throw an exception, we will add the exception to the methods throw list. But you should know that the implications of doing this would be that the interface that your classes implement will also have to be changed, and we will make those changes in the interfaces as well. So now we are good to deploy these methods on the Glassfish server. As discussed earlier, the implementation of the JAX WS API that we are going to use is going to be Metro. Metro is bundled with the Glassfish server. Now the question is, what should be the next step? How will it be possible for a client to remotely invoke these methods? Now, a client can invoke these methods by using what is known as a WSDL. A WSDL stands for the Web Service Description Language. It's an XML-based document that is used to describe your SOAP-based web services. Let's first take a look at how the WSDL looks like for the web services that we have created so far. To do this, you can open your browser and type out the URL of your SOAP service. You can find the URL of your SOAP service in the logs of your Glassfish server. This is the URL of my SOAP based service. I'll take a copy of this URL and I'll put it over here. To view the WSDL of this SOAP service, I can add a query parameter to this URL and type WSDL. This is the WSDL for my Shipcart service. If you look closely at the WSDL, you will see that it describes every method that you have implemented as part of your service. For example, the get item details method, the get coupon details method, the get order details method, and so on. So all in all, the WSDL represents all the different business service methods which can be remotely invoked by a client. You can find all these methods inside the port type element. The methods are listed under the operations element. So that gives you a fair bit of idea about what SOAP is. This is the reason why we call it an XML based protocol. This is the standard format of the WSDL. A client can use this WSDL to regenerate artifacts like Java classes on its own end, and then the client can use those stub classes to invoke methods on your SOAP based web service. What we are going to do is, since we need to very quickly test these SOAP services, we will do this testing by using a tool which is known as the SOAP UI. SOAP UI is a Windows-based tool which can be used for very quickly testing not only your SOAP services but also your REST-based services. On the SOAP UI, I'll create a new SOAP project. While creating a project, you need to give a name to the project. Along with the URL of the WSDL. You can take a copy of the URL from your browser window. And click on OK. As soon as you create a new project, SOAP UI retrieves, or you can say imports, the WSDL from the server, and after importing the WSDL, it lists all the different methods which can be remotely invoked. You can choose any one method of your choice. For example, if you intend to test the getOrderDetails method, then this is the request that you need to send from your SOAP UI. The request contains an XML document in the request body. The XML document contains what is known as a SOAP envelope. The SOAP envelope is also known as the SOAP message. There are two parts to the envelope. The first one is the SOAP header and the second one is the SOAP body. This SOAP message is sent to the server by using the HTTP protocol. The method that is used to send this request using the HTTP protocol is a POST, and this is something that is very common with SOAP-based web services. SOAP-based web services primarily use, as I said earlier, the HTTP protocol as a transport medium. They use the POST method in the protocol to send this XML and to receive a response from the server. You can specify an order number over here. To get the order number, you can go to your Shipcart DAO class and you can pick an order number from here. The order numbers are being randomly generated. So let's try with an order number 320. To send this request, you have to click on the submit button here, and that should give you back a response. This is a HTTP response. If you look at the response again, this is the body of the response. The body of the response contains a SOAP envelope. The SOAP envelope again contains a body, that is a SOAP body, and the SOAP body contains the details of the order. You can test the other methods as well. For example, I can test the getItemDetails method. This is the SOAP message that will be sent to the server for invoking the getItemDetails method. If you remember how the method was written, you will understand that the getItemDetails method, this is the name of the method, and it has one parameter which is the item code. The name of the parameter can be seen in the SOAP message that is part of your request. You can send the item code over here. Let's say, for example, I pick up this item code. And that should again produce a response which contains details of the item. So this is how you can very quickly test your SOAP services by using the SOAP UI tool. Apart from this, what you can also do is you can write a client in Java which can attempt to remotely invoke your SOAP services. Let's do that. So in this very workspace, I'm going to create a new project. This is going to be a standard Java project, a console-based application. Let's call it Shipcart Client. I'll create a package. In this project, which will have the main method. Now the question that comes into play is, how can the client have access to the artifacts that were generated on the server side? The artifacts that the client needs access to is the stubs, which can be used to remotely invoke your SOAP services. Apart from that, the client will also need access to the different Java Bean classes that were created while implementing your SOAP services. The reason being, those services return back domain objects. Though they may be returning back those domain objects in the form of XML, that XML might need to be converted back into a domain object when these SOAP services are remotely invoked from this client. To be able to do this, the first thing that we will do is, we will create a package in this application. Your clients can use a tool provided with your JDK, which is known as the WS import. The WS import tool is a command line tool which can be given the URL of your WSDL. It uses the URL of your WSDL to read the WSDL document and generate artifacts like stubs and other classes on the client side. The WSDL tool can be executed from your operating system's command prompt. You must execute the WS import command line tool from the project folder where your client code has been written. Of course, it is not mandatory to do this, but the advantage of doing this is that the artifacts would be generated directly into your project folder. The syntax for using WS import is WS import followed by the name of the folder where your source files have to be kept, followed by the name of the folder where your class files are, minus keep, which is an indication to the import tool that you intend to keep the generated artifacts, followed by the URL of your WSDL. You can take the URL of your WSDL from your browser and that's it. The moment you do this, you can go back to your Eclipse project and refresh your project, and you will see that the WS import tool has generated a series of artifacts by using the WSDL. You can use these artifacts to remotely invoke your SOAP services. Let's do that. The first thing that you have to do is you have to create an object of a class known as ShipCart implementation service. This class has been provided to you by the WS import tool. The next thing that you have to do is create an object of ShipCart service, which is another class, which is another interface provided to you by the WS import by reading the WSDL. To create an object of this interface, you have to invoke a method on your ShipCart implementation service object, which is called get ShipCart implementation import. And now you can invoke a method on your ShipCart service object. You can invoke, let's say for example, the get order details method to retrieve the details of an order. The SOAP service has already been deployed. We did not shut down the server, so we can directly go ahead and execute this main method. and there you are. So this is a console based client written in Java which attempts to remotely invoke your SOAP based services. So let me quickly summarize what we have done so far. SOAP stands for Simple Object Access Protocol. If you look at what it stands for, you will understand that SOAP is a mechanism to implement web services wherein clients can remotely invoke methods on your objects. Since it is a protocol, SOAP is an XML based protocol. It uses rules followed by well-defined XML documents to remotely invoke methods on your objects. Your SOAP web service is described in what is known as a WSDL. The WSDL stands for the Web Service Description Language. It contains the description of all the different methods that you have implemented as part of your SOAP-based web service. Clients can use the WSDL to generate stubs and remotely invoke methods on your SOAP-based service. You can also use tools like the SOAP UI to very quickly test your SOAP services. SOAP uses the HTTP protocol as the transport medium. It uses a HTTP post to transfer XML documents from the client to the server and receive an XML document in the response. We have already seen the format of these XML documents that are sent in the request and received in the response. You can see the XML documents on your SOAP UI. This XML document contains what is known as a SOAP message. The SOAP message, or what is also known as the SOAP envelope, contains two parts. The first one is the SOAP header and the second one is the SOAP body. That brings us to this to the end of this session on SOAP web services. If you have any questions, please do post comments on this video. Thanks for your time.